Hey, it's Tom, and this is another video about data structures in Swift. Today we're going to talk about sets, so let's start with basics. In general, set is an unordered collection of elements in which each element appears only once. You can think about set like a dictionary in which there are no values, so a dictionary containing only keys. And same as in case of dictionary, under the hood, set is implemented using hash table. So each element which will be stored in a set has to conform to a hashable protocol. The good thing is that in Swift, all basic types like string, integer, float, boolean, and so on already conform to hashable protocol, so you don't have to implement your own hash function. You can just use those elements as elements of set, and that's working out of the box. Another good thing is that if you will want to use structures or enums and keep them in set, you can also build them using just basic data types like strings, integers, and so on. And as long as struct or enum is built using these basic types, it also conforms to hashable protocol out of the box. And you don't have to implement your own hash function. That's very time saving. And the another good thing about set is that checking membership of element in set is constant time operation. This is a big difference between, for example, array and set, because in array checking membership of element grows linearly if we are talking about time complexity. So the bigger is the array, the longer it could take to verify if the element is in this array. And in set, it's in general constant time operation. So if the set will contain 10 elements or 10 million elements, in general, it should take comparable amount of time. And what I have also noted is that, yeah, the sets, like any other collection in Swift, are strongly typed. So let's maybe talk about use cases for set. So when you want to ensure that your collection contains no duplicates, then set is a very good choice. It's probably the most efficient choice. Another use case might be a case in which you will have to check membership of an element in a collection many times. And if you will use array, it will be definitely much more time consuming, and if there will be a lot of elements, your program will slow down. And in case of set, it's in general constant time operation, so it shouldn't take a lot of time. Okay, so maybe let's switch to the code, and I will tell you more about details of sets in Swift. Okay, let's start with creating sets. So as in case of any other variable, you can create immutable and mutable versions of set. So as in any other case, if you would like to create an immutable set, so both the size and the data with the size of the set and the data within the set will not be modified in future. So for example, let's start with immutable data. For example, we can use a collection called Mazdas. I will use Mazda models. I'm a big fan of cars, so that's why I will use it. And we can create this set using array literal. So we'll both create the object and assign all values at once. In this case, we have a set of type of objects which are string type. And of course, we can do this without declaring the data which will be in set in the same time. So we can do this like like this. Okay, and then assign the data. That's working in the same way. Yeah, so we have whole collection right here. And to be honest, usually I see rather this kind of declaration. And as in case of course, we can make it mutable, and then we can modify it, delete, add elements, modify them. Of course, we'll go to this part later on, but as for now, let's leave it as it is. And then let's create a mutable version, so we will be able to add and remove elements. We can call it, for example, European Mazdas. And we will use string. And now we will use an initializer syntax, which is less common, at least from my experience. Yeah, we can European Mazdas. There is no Mazda CX-9 in Europe. So yeah, that's it. And we can also declare American Mazdas, also using the maybe no, maybe just copy and use array literal syntax. And yeah, let's just define that it's a set, not an array, because in this case it will be just an array of strings. Now it's a set, so we can remove CX30. I think there is no CX30 in US. Anyway, if there is, that's still not important. And the good thing is that there will be no error. Print. Even though we put a duplicated element like Mazda MX-5, but if we'll print out the data from American Mazdas, there is no duplicate. So that's good. I think that's good thing about sets, that there is no error. It just ignores the duplicate element. Okay, so as in case of any other collections, of course we can check if the set is empty, and we can also check the count of all elements. So the set is not empty, that's true, and the count is 8. There are 8 elements in this set. Okay, let's see how we can modify the set. So at first, maybe let's insert some data. We can remove MX-5 from European Mazdas, and now so we will use insert new member, and it has to be string because our set contains only strings, and this will be MX-5. European Mazdas. Yep, it's there. Of course, we can also check if particular element is in the set. So contains MX-5, and that's true right now. And without this, it's false. Yeah. That's looks like working pretty fine. Of course, we can iterate through the whole collection, like in case of any other collection. So we can use for simple for loop, and for model in Mazda's. Let's call Mazda's. Maybe let's print model uppercased. Oh, they are uppercased, of course. Yeah, so that's the output. And yeah, so we already iterated through the elements. We can also try to delete elements like European Mazda's remove MX5. Why not? And we can print European Mazda's right now. We can comment out this loop because it takes too much space. Yeah, and as you see, there's no MX5 any longer in Europe, and that could be true soon. We can also delete, of course, all elements, and yeah, that should give us empty set. And right now, if we will check the Mazda's is empty, that will be true. Okay, so maybe avoid deleting all the elements, maybe even avoid deleting MX5. That's a pretty good car. So now those were very basic operations that you can do on any other kind of collection in Swift. But now let's go to a little bit more tricky part of sets. So in general, sets in Swift works with set algebra. So the same algebra you were learned at school about sets in math. So the first interesting thing, let's call it, yeah, set algebra. So at first we can subtract elements. So we can delete elements from one set, which are in one set, from another set. So let's call it let Mazda's unavailable in Europe. And that will be all collection of Mazdas, subtracting those which are available in Europe. European Mazdas and Mazdas unavailable in Europe. Yeah, so as you see, it's CX9 because there's all Mazda models, and in Europe we don't have CX9. So yeah, the only difference between those two sets is CX9, and that's the effect of subtracting. Maybe let's delete it. So yeah, subtracting data. Another popular operation is intersection. So we check which elements are in both sets. So for example, intersect. So we can check which Mazda models are available globally. So are commonly in American dataset and in European dataset. So let global Mazda models, it will be European Mazdas intersection with American Mazdas, and print global Mazda models. Yeah, so those models are available globally, and that's probably true. Even in Japan, they are available, as far as I know. Another popular operation, which you were learning on math at school, is probably creating union, so joining all elements from two sets or more, and just ignoring the duplicates. So it's just like adding two sets but without duplicates. So union let all Mazdas, and it will be American Mazdas union European Mazdas, and print all Mazdas. Yeah, so as you see, we printed out the set which contains all elements from the first set, the American Mazdas and the European Mazdas. And there are no duplicates because set doesn't allow to have duplicates. Okay. So we can also check equality of two sets. So all Mazdas equals Mazdas. Yeah, that should be true. Yeah, because they both contain the same elements, and that's it. There are also two operations that we can use to verify if one set is a subset of another, or if the first one is a superset of another. The subset means that the elements in one set are also within the other set. All elements from one set are in the second set. So let's maybe jump to a example. It will be much easier to check that. Let's check if one set is a subset of another. So European Mazdas is subset of Mazdas. That should be true. Yeah. And European Mazdas is subset of American Mazdas. That's definitely not true, because they differ. So American doesn't contain the CX30 and European doesn't contain CX9. Yeah, so I was wrong. So even though that American doesn't contain, even though that European doesn't contain CX9, it doesn't really matter. The most important thing is that American Mazdas doesn't contain all elements from European Mazdas set. So it doesn't contain CX30, so it's not a superset of European Mazdas. And as a result, European Mazdas is not a subset of American Mazdas. Okay, and it also works in a pretty funny way. So Mazdas is subset of Mazdas, of course, but is strict subset. Is strict subset checks if the first set is subset of the second, but it's not the same set. So it has to be smaller, at least by one element. And this logic could be used also in an opposite direction. So you can check if one set is a superset of another one. So for example, Mazdas is superset of European Mazdas, of course, but Mazdas is strict superset of Mazdas. Of course, that won't be true because that's still the same element, but it will be a strict superset of European Mazdas, as you see, because it just contains more elements. It's not the same set. And there is last operation, which is called disjoint, and it checks if there is an overlap between two sets, and the result will be true only if there will be no overlap between those two sets. So we cannot use to any of these sets for this, disjoint. But we can let Tesla, yeah, Tesla might be a good set because it's there are not so many models. So there's S, 3, X, and Y. Pretty interesting. Okay, equals, yeah. So we can check if Tesla is disjoint with Mazdas. It's false. Okay, there is Model 3. In general, Tesla Model 3 was planned to be Model E, but you know which word is being created. So yeah, maybe let's just delete the Model 3 from the models of Tesla, and right now it will be true because there is no overlap. There is only S, X, and Y in Tesla and other models in Mazda. Okay, looks like we are finally there at the end of this video, and as usually, thank you for watching, thank you for your time. If you have any questions, please let me know down in the comments section. I will be more than happy to help you. Of course, this playground will be cleared a little bit and will be linked below the video. And that's it. Thank you for watching. See you next time. Bye.